So here's vectors. Yeah. So let's let u equal the vector 3, -2, and v equal the vector -2, 5. And let's find component form and magnitude, or the lengths of the vector. Magnitude and lengths are used interchangeably at times. So basically in this first one you have 3 times u, vector u. That's what this arrow means, it means a vector. It can also be used in boldface, and there's many notations, but when you're writing by hand, usually an arrow above the thing is the best symbol. But this is just a scalar times a vector, so it's just you multiply into it, both of them, and you get 9, -6 from 3, -2, because it's just 3 times them. And of course for this one, b is magnitude. I think just 1 is plenty good. I mean, 1 is just good. I added 2 in this section for some reason, but 1 will get the point, basically. It's the magnitude for these lines, and that's usually used, but I guess I saw it being used like this once, so that's why it's included this time. But regardless, just one set of bars. And then you basically take the square, basically magnitude of a vector with 2 components will be just one set of bars again. Just remember that for now. Is just the square of both of them added together. v1 squared plus v2 squared. So 9 squared plus -6 squared. You get square root of 117, which is equal to 3 times square root of 13. So 10 for 5, the same thing. It's now 2u minus 3v, so a is 2 times 3 -2 vector minus 3 times 2 5. And it's equal to, and you can add vectors together, of course, as I do here, step by step. Eventually you get 6 plus 6 and -4 minus 15 for the 2 components. You get 12 and -19. That's the component form. And then the magnitude of the vector will be given by 12 squared plus -19 squared, the 2 components, squares of them, square root of them, and then it's equal to square root of, ends up 505. And the magnitude of this vector then is just square root of 505. You can't simplify it anymore. So let's find the component form of vector for the following. These two bounds basically just, you have vector pq where p equals 1, 3 and q equals 2, -1 coordinates. So in this case, the point, you'd have, you just subtract the second one by the first one. You take second minus first. So 2 minus 1 and -1 minus 3. And it's very important that you keep these ordered here. You do end beginning, end minus initial, basically. So sort of like that. And the vector from the point a equals 2/3 to the origin, and origin we'll say is a big O, and it's equal to 0, 0. So we can show the mass here. Basically, you're going from a to 0, so it's 0 minus 2 and 0 minus 3 are the 2 points used, basically. Subtraction, and you have -2, -3 as its coordinates. Just go to vector. Basically, the vectors form the component form by components here, these two different bombs. And yeah, in general, basically, if you let x1, basically it'll be the vector AB, as terminal point and initial points, you'll have that x2 minus x1, y2 minus y1, and z2 minus. And here, these problems involve expressing each vector in the form of v equals v1i plus v2j plus v3k. And so the point is, these are the 2 points here. You basically do the subtraction method and get And we'll just do this. We'll get a component form, and then we'll just add on I, j, and k, which is one way to do it. Basically multiply 3 times I plus 2 times j minus 1 times k. So same idea, component forms, and we just add it on. We add on it. It's one way of doing it, at least when you're limited like this. But this one is 5u minus v if u equals 1, 1, negative 1, and v equals 2, 0, 3. Just that's multiplying a scalar into a vector and it's subtracting a vector basically. But overall it's very similar to algebra. This is basically like a form of this is algebra but with vectors. That's all it is. So yeah, eventually end up with exponents 3, 5, negative 8, which implies that 5u minus v is equal to 3i plus 5j minus 8k in that form. And expressing each vector as a product of its lengths and direction. So if you have 2i plus j minus 2k, you basically I use single bars now. And it's a square root, it's basically like the lengths, the magnitude basically. You have to find that first. And it's equal to 3. Because you should do the math, 2 squared plus 1 squared plus negative 2 squared will equal 9, and the square root of 9 is 3. Then 2i plus j minus 2k is equal to 3 times, because it's formula down here. V equals magnitude of v times the vector v divided by magnitude of vector v, So yeah, so we do. So it's a divide, basically, and then it's 3 times. You can keep it as this form. 3 times 2 thirds I plus 1 third j minus 2 thirds k. And keep them separate. Keep this 3 outside here. So the same thing as the last part we did. So 5k, we want to write this. It's a little bit easier than even the other one. As a product of its direction and magnitude, or length and direction, I mean. Magnitude also work because length and magnitude are pretty much interchangeable. But a product of its length and direction, well, we can write 5k as 0i plus 0j plus 5k. So 5k is equal to 0 squared, square root of 0 squared plus 0 squared plus 5 squared, which is equal to square root of 25, which of course equals 5. Then we can write up 5 as the formula before. We have the magnitude of the vector v here, and then the vector v. And yeah, we can simplify by 0 divided by 5, 0 divided by 5, 5 divided by 5. So it's 1 times k basically is what turns out to be direction. So just k. And length is 5. Now here's a question. Look at Pondo. Find a vector of magnitude 7 in the direction of v equals 12i minus 5k. So we are given this as direction in a magnitude of 7. So direction we know is equal to v over the vector v divided by the magnitude of vector v. So 12i minus 5k, then the magnitude down here, magnitude of length. And then we can continue from here. We have square root of 169 eventually, and then that's a perfect square, so it makes 13. Then you have it all equal to, so the direction will be 12, 13i minus 5, 13 over 13k. And the answer will be in this form, of course. We basically have it now. And a magnitude of length still, as a whole, is 7. Is the vector we want. It's a specific one, so 7 times the direction of 12, 13i minus 5, 13k. So one last problem in this area topic of just plain vector math is that let's find the direction of P1, P2 vector of these 2 points basically, and the midpoints of line segment P1, P2. So P1 is given as negative 1, 1, 5, and P2 is 2, 5, 0. Those are the coordinates, x, y, and z. So the vector will be, of course, just subtraction of P2 minus P1. Because that's the second minus the first. In order that it's depicted. Then you basically get IJK format. as before, I is associated with x values, y was j, and z was k. Otherwise, you get 3i plus 4j minus 5k. And we need to find direction of this vector. So it's just the vector itself divided by the magnitude of the vector. Just square root of 3 squared plus 4 squared plus negative 5 squared. To solve for square root of 50, it becomes 5 square root of 2 on the bottom. And you can individually divide them out, because that way you get one of these simplify down to minus 1 over square root of 2k here. The rest is, as highlighted out here. What did you do? And the midpoint formula for any 2 points in x, y, and z is given as x1 plus x2 divided by 2 is x coordinate, y1 plus y2 divided by 2 is the y coordinate, and the z coordinate is z1 plus z2 divided by 2. Yeah, you're just taking a simple average of 2 points. Negative 1 plus 2 divided by 2 will give you 1/2. 1 plus 5 divided by 2 is 3, and 5 plus 0 divided by 2 is 5/2. So yeah, it's just following the formula for midpoint. That's why there's only like one example in this whole thing.